Hi, good morning.
Hi, good morning.
I took his countdown, by the way. All right, so we've been playing with polynomials. That sounds fun. Playing with polynomials. We did some addition and subtraction. We did some multiplication. We did long division, and now we're going to be using them to write quadratic equations given the roots. Now the roots mean the solutions. It means the value that x equals. It's, if I were to draw them on a calculator or on paper, it's where the graph touches the x-axis. So we're going to start with that information, then do stuff with it to get the equation that then you would type in your calculator to have it draw the picture for you. Okay? So here is what all of your items are going to look like. Remember that squirrely bracket means the set of, and we're going to transform it into stuff that looks like this. 4 steps. That's all there is to this. Step number 1, get your solutions and set them equal to x. Step 2, solve each of these little equations so that it looks like stuff equals 0. Okay? You want to turn these into equals 0. Feels like we're solving in reverse, right? I subtracted 4 from both sides on the first one, and I added 2 to both sides on the second.
So we just change these answers.
Yep, basically. Now, I'm going to grab each one of these 2 things and multiply them together equals 0. Okay? I'm not going to do the multiplication. I'm just going to write, hey, multiply. Okay? So this first thing times this second thing equals 0. Now that I've got these 2 things listed as multiplication, now I'm going to multiply. And to multiply these, it's distribution. X times x is?
X squared.
X times 2 is?
2x.
Negative 4 times x is?
Negative 4x.
And negative 4 times 2 is?
Negative 8.
Negative 8?
Yep. Simplify it, so look for like terms to combine. I have these 2 things as like terms. I've run out of space. 2 minus 4 is negative 2, and so there is the polynomial, the quadratic equation, that when I type into the calculator will give me a picture that intercepts the x-axis at 4 and at negative 2. Those are the solutions, those are the roots. Here is the question that you would solve for x to get these 2 answers.
So we wouldn't completely solve it?
You wouldn't, it's already, we already started it solved.
Oh, okay.
We're trying to find the question that you would have to have solved.
Because yeah,
okay.
Yeah,
like the equation. We're pretty much just,
exactly.
Yeah.
That's exactly what we're doing. We're finding the equation. Easy enough?
Mm-hmm.
The steps stay the same even if the solutions look weird, like fractions. Let's do this one because I know some of you are going, oh God, I'm getting hives. There's fractions. Step number 1 was?
Oh, x equals
X equals these things.
2.
Good. Step 2,
Equals 0.
get them to equal 0. Beautiful. Step number 3,
Oh, distribute.
multiply them because step 4 is distribute. X times x is x squared. X times negative 3/4 is? Yep. Negative 2/3 times x is?
Negative 2 or 3x.
Good. And negative 2/3 times negative 3/4. I don't know. Let's work them by hand because you were definitely smart enough to do these by hand. First off, is the result going to be positive or negative?
Negative.
Positive because we've got 2 negatives. So I know it's going to be negative. And then I'm going to write that I'm going to multiply the fractions. I'm not actually going to multiply them. Just going to write that I have to do it. And I'm running out of space, so I'm going to bring all of this up here onto a new column. Okay? So I'm not making any changes yet, just moving it over. Bless you. Okay, so I've moved it over. That's all I did. I just moved it over. All right. I can do multiplication of fractions. How do you multiply fractions?
By multiplying.
Is it across?
Straight across. Not cross multiply. Multiply straight across. All right. So 2 times 3 is,
6,
and 3 times 4 is,
12, I think.
yep. All right. Everything else is going to stay the same. I like that question, but can't you simplify? Yes, I could. I'm not going to right now because I want to show you there's a bit of a relationship between that last term of my trinomial, the thing with 3 terms, and the middle term of the trinomial that we're going to get after we add those fractions. Okay? Great observation, though, on the final answer. It doesn't matter to me whether it's simplified or not. All right, now I need to subtract these 2 fractions, which I can't do unless there's common denominators of the same number on the bottom. So what I'm going to do is I'm going to find a common denominator. In order to find a common denominator, we need to be thinking least common multiple. Back from, 3rd or 4th grade when we first learned common multiples. Here's how we do it. I'm going to list 3 and 4. Going to grab 3. Now I'm just going to count by 3s, and I'm just going to list out their numbers so I don't have to think. 3, 6, 9, 12, 15, 18, 21, 24. I'm going to stop there because that's already a lot of numbers. I'm going to do the same thing to 4. Start at 4 and count up by 4, and I'm going to write the numbers that I'm counting. 4, 8, 12, 16, 20, 24, so on. I'm going to stop because I've run out of paper. The one they have in common is the 12. It is the first one they have in common. That is their least common multiple. That is their common denominator. It's coming back to you? Mm-hmm. Okay, good. So I'm going to rewrite these fractions with a 12 in the bottom because that is my common denominator. I've left the tops blank because I've got to do some figuring out. All right, on the first fraction, this 4, what do I have to multiply to 4 to get to 12?
3.
That's what I'm going to multiply the numerator of that fraction by. 3 times 3 is 9, and so the new numerator is 9. You can do the same thing to the next fraction. What do I multiply to 3 to get to 12? That's what I'm going to multiply the top by. 4 times 2 is?
8.
And there are my 2 renamed fractions. I know for sure they're equal to the original fractions I was given. They now have the same denominators. I can now add and subtract them. How come this is a negative? Because I have a negative 9 minus 8. And when you're adding, the signs don't change. It's when you're multiplying that a negative and negative becomes a positive. This isn't multiplication. This one seems more complicated than the last, but let's review. The 4 steps to going from solution to equation were: write the solutions as x equals, rewrite it as equals 0, multiply the things together, distribute, and simplify. Same steps as before. It's the simplification that on this one was a little more complicated because we had to deal with fractions. Okay?
And then the next one we're going to have to do square root.
Maybe. Right, let's look at the next one.
Don't you divide to cancel it out?
I love these questions. Do we divide to cancel these out? Do we take the
Isn't it the exponent?
or do we do something with the exponent? Let's play with it. Let's follow our 4 steps that we did before and see what happens. I love that you're asking these questions. All right, my solutions are square root of 3 and negative square root 3, and so step 1 is to set those equal to x. Step 2 is
Equals to 0.
make them equal to 0. Step 3 is
Multiply.
multiply them. Step 4 is distribute and simplify. All right. X times x you told me was x squared. X times square root 3 is
X
square root 3x. Typically we write those variables at the end.
Why is it outside?
Why is it outside? Because it's not inside of a radical itself.
Oh, okay.
Yeah.
So you just add it at the end.
Yep. Negative square root of 3 times x is
Oh,
Three.
-3.
negative square root 3 x. Negative square root 3 times positive square root 3.
Negative square root.
They cancel negative the square root of something. What? Okay, pause, deep breath. The answer, positive or negative?
Negative.
For sure negative, because I'm doing a negative times a positive, so I'm going to write a negative. Now I'm going to write square root 3 times square root 3. I'm not going to try to multiply them right now, just going to write that I have to do it. Okay, let's go ahead and deal with this one first. This is multiplying radicals. We did multiplying radicals back when we did, I think the square root units. We may have done it in geometry if you had me last year when we did something called geometric means. And then you saw in Algebra 1 where we played with it. Here's the rule to multiplying radicals. To multiply radicals, you need the following things to be a match. You need the indexes to match. There's supposed to be a C in there. Okay, that's the only thing that you need to be a match. No one cares what's happening inside of the radical. Okay? So, don't need to match. Once you have the radicals matching, you can rewrite it with keeping the index. Don't change it. But you're going to multiply the things inside. Okay? And it doesn't matter what those things are. You're just going to multiply them inside. Okay?
So you multiply the x with the smiley face.
Sure. So here, we rewrote it as one radical, and we're going to write the two things inside multiplied together. 3 times 3 is?
9.
Square root of 9 is?
3.
So your gut feeling of, hey, those radicals are probably going to cancel out somewhere, or maybe we're going to square something, totally happens.
But like, only if they're different, the thingies on the outside.
If the thingies are these little tiny numbers, the indexes are
Yeah.
different, you cannot multiply them.
Oh, okay.
You can only multiply them if the indexes match. If there isn't an index, it's 2.
Okay.
So they're not equal, the little ends?
The little
What do we
ends.
do in that case?
Nothing, you just have to leave them like that. There's nothing to do yet.
Okay.
Nothing to do yet. All right, now let's handle this thing. This is adding and subtracting radicals. To add and subtract radicals, it's going to feel a lot like combining like terms. With to combine like terms, you had to have the same variables, and those variables had to have the same index, right? Yes? Yes. So to add or subtract radicals, you need to match both the index of the radical and the radicand. Okay. So both of these things have to match. The moment you get both of these things to match, whatever number is sitting right out here, and if there isn't a number, it's a 1, becomes like a counter. I have one of these things. and one of these things. How many of these things do I have? I have 2, because 1 plus 1 is 2. And so with adding and subtracting radicals, you just make sure that you have a complete match with index and the thing inside the radicand. And then you can take those numbers out in front, the big ones, the coefficients, and add or subtract them like normal, and then just copy the radical at the end. Okay? All right, let's look at this. Does this have a coefficient, a number in front?
No.
No, so we're going to put a 1. What about this one?
No.
No,
Yeah,
we're going to put a
never
1.
mind.
So now I have plus 1 minus 1. Plus 1 minus 1 is?
0.
0.
I thought
So I have 0 square root 3x.
I thought I was gonna have something because of the negative, but never mind.
Okay,
That only works with parentheses, right?
right.
Oh, okay.
0 times stuff is,
0.
do I need to write the 0?
No.
All right. So your gut feeling of stuff is going to cancel happened right here.
Does it cancel just because it has the same number?
Yes, it canceled because the radicals were like radicals, which means they had the same little index that was missing, and the stuff inside the radicand. And it was like terms because it had the same variable with the same exponent.
So if the one in front of it had the plus 3, it had a 2 in front, and the other one didn't?
If it had a 2 out here,
Yes.
that would be fine because now I would have 2 of these and 1 of these and I could still add them. It would be if in here I had a 2.
Ah.
If there was a 2 inside and this one had a 3 inside, I couldn't add them because they're not the same radical. The numbers, the big numbers out in front are like counting numbers. All right. And then I'm going to bring that x squared down. I don't need to write the 0. That's my answer.
Oh, wow. Like a lot more work than the other one.
Okay. His comment was, it looks like it's a lot more work than the other one. But those 4 basic steps remain the
Yeah, it's
same,
just
yes?
the same from like the first example.
Yeah, the steps remain the same to getting to the equation. The only thing that's happening is this simplifying step after we distribute. There's a little bit more work depending on what we've been given. Fair enough? Let's look at example 4. All right, it says solution is that.
I have a question. What is that?
Yeah, that's a great
Oh,
question.
plus or
What is
minus
it?
5.
Yeah, it's a plus or minus sign. So this basically means plus or minus. It means in that 2 symbols, you have 2 numbers.
Oh, so it's an easier way of writing plus 5 minus 5.
Exactly. It's because we math people are lazy. I don't want to write 5, comma, negative 5, and then in this, otherwise I'd have to write this. Like, I don't want to write that. That's too much writing. Like, no. So instead, I'm going to do this and be like, boom, shortcut. It means this, which is exactly like example 1. Do you need to see this one again? No. There's one more example that I want to give you. And this will be the last one.
Wait, that's it?
Well, then you'd have to go back and do your steps from example 1. But it looks exactly like example number 1. Because they're just whole numbers.
Oh.
Yeah? All right, example number 5. Example number 5 is, someone give me a number, any number.
233,000.
Okay, well.
Sure, 233,000.
Oh my god.
Lovely. Deep breath, relax. Look, that's the only number that's sitting in there, right? But these are quadratics. How many answers should there be? 2, which means this one answer shows up twice.
Like,
This one answer covers both of them.
positive and negative.
They're not positive and negative. They're both positive. They're the same number.
Oh, okay, never mind.
And so you do all the things that you do in the other ones, but you're going to use the same number.
I was just gonna stop at 233, but like, why not make it big?
Why not, right? We're not actually going to do this one because those numbers are really big and I have to run to a calculator and oh my god, I can't think.
5.
No!
How about 10?
But the process
Yeah.
remains. Do you want to see the worked out process for something like this?
No, I kind of get it
Because it's gonna be exactly like this one. The difference is that like if we look at our homework assignment, and you look at like number 19. What? Well, because the 6 appears twice, so you're gonna do x equals 6 and x equals 6, and then you're gonna run it from there. They're both positive. They're both whatever sign it says there.
Miss, so like the ones for like 22, like it'll be like examples 3 and 4.
Yes, together
Oh,
at the
okay.
same time.
Think positive or negative square root of 15.
Yeah.
But positive or negative 3. And
Yeah. Yep.
Can you do some examples on the homework?
Some examples from the homework. Sure, let me cut off the recording and then we'll work as many of them as you want. Thank you very much.
bye.
Bye.